Okay, so students, now I'll show you the fifth experiment of Advanced Physics 1 lab. This experiment is called diffraction of light. Diffraction is one of the phenomena which proves the wave nature of light. Interference is also one such phenomena which proves the wave nature. So first I'll talk about what are the different elements which we will require here. So I'll start with this optical rail, okay, because we need longitudinal alignment only. And on this rail there is the laser that we considered was similar to the last experiment, which is the diode laser, which is emitting red wavelength at 632 nanometer. The typical power is 5 milliwatt. Here is a post holder and a mount which is called a diffracting element mount. So by the term diffracting element, I meant to say that when light interacts with a medium whose dimension is slightly larger than the wavelength of the light itself, then the transmitted light will not give you a uniform intensity distribution. There will be a variation of it, okay? And how the intensity will vary depends upon the dimension or the geometry of the diffracting element with which light interacts, okay? So for example, here the diffracting element is called mesh bead, okay, and you'll see there is a distinct intensity distribution. Other than this, there are various such elements which you need to study. So I'll take the readings for all these elements and I'll share the data with you. Okay, now how do you see the intensity variation? I can show you the intensity just after this. You see? However, to get the actual variation, you need a pinhole detector with a very small hole diameter, right? So that you can scan it along X and along Y. Or else what you can do, you can see the intensity pattern on the wall itself. I think you can see the intensity variation, right? And the beauty of putting this intensity pattern on the wall is that you can easily resolve the intensity zeros and intensity maximum, right? So we'll actually use this procedure to locate the intensity minimum and the intensity maximum. And I'm pretty sure that you would like to see this intensity for the other elements too, right? So what I'll do is that in the next video I'll focus on the screen only, and I'll change the diffracting element 1 or 2 and I'll show you how it gets changed. However, having said that, I have taken the images for all the diffracting elements, which I'll also share with you. Okay, so that's all for the experiment. In the next video, I'll show you the intensity variation with the changing by changing the diffracting elements. Okay, thank you.